Welcome to the second Bendtech 7X sheet metal plate tutorial.
Before we start, we're going to go over some things that all of our customers should come to understand in order to use their software efficiently. There is no TriStar in the Sheet Metal Designer, but you can simply visualize your design from a bird's eye view. The X and Y axis point in the display area is referred to as the origin, and will be the starting point for most projects. To access a third dimension view, you need to change it by clicking the Display drop-down menu and changing the display to either 3D wireframe or 3D shaded.
PickPoints are used for everything, so what are they? PickPoints are simply points in 3D space created by the user that are meant to define where the parts in the project will be placed. Once PickPoints are placed in the display area, you can build off them by using them as reference points for other points. Most of the time, you can think of them as the end of your tape measure.
The apex of a bend is really the intersection of the two outside lines or two inside lines, as if there wasn't a radius.
This applies on all sheet metal bends. When Free Select is activated, the points that are made in the display area are not confined to a specific area. Every point will be placed exactly where the user clicks the cursor.
When Free Select is deactivated, the new point will be placed by using the nearest point as a reference. This is true for not just points, but lines, arcs, holes, and other things.
When creating bent parts with the Sheet Metal Designer, it is important for you to remember that the bending radius is the inside radius of the bend. Start the project by opening the Bendtech software to the task menu screen and selecting the plate icon from the list as seen here. From here, maximize the screen and select the incremental option to the left under the Point subtab. Now type 62 into the X field and click on the origin to place a point. Then, zero out the X field, type 57 into the Y field, and select the origin and the other bottom point to the right. Now, zero out the Y field, type 31 into the X field, and click the upper left point. Then, change the X value to 35.5 and click the same point. Place a minus sign in front of the X value and click the upper right point this time. Now, you should have all symmetrical points on the screen. Now, change the X value to a negative 32.5 and click the bottom right point. Finally, delete the minus sign in the X field and click the bottom left point. Now, to create our defined edges, select the Line subtab, click on the Continuous checkbox, and connect the dots as seen here. Click on the Cancel button to discontinue the line feature, and click on the Part tab from above to apply a material. Select the Library button and you'll see the material list and the option to add a new material to the library. We will be using a 1/2 inch thick material with a 1/2 inch bending radius for our purposes. Close this window and select the material from the drop-down menu and define the flange as seen here. Now switch to the Bends subtab to add extra flanges to the design. Change our bend angle to 60 degrees, our flange initial height to 3 inches, and the direction to down. Then select the 0.5 inside bend radius from the drop-down menu below. This can be added to the material by clicking on the Library button and adjusting it to the right. When these options are set, select the blue New button and create 2 flanges on either side of our base flange. Then go back to the Definition sub-tab and select the Define All button. The new flanges will then be defined as part of the project. To check, select the Display button from above 3 times and you'll view the part as a 3D model. Now we will attempt to trim back parts of these new flanges, but first we'll place some points as references to draw additional lines. Go to the Create tab and switch to the Point sub-tab. From here, create points 1 inch outward from either side of the bottom edges of the part. Then zero out the X value field and type 58 into the Y field. Now select each of the new points to place new ones 58 inches above them. Afterward, go to the Line sub-tab to create 2 vertical lines by connecting the bottom edges of our part to the top new points as seen here. Make sure that the flange you're working on is selected from the flanges list above. Otherwise, it will not be added to the design as a legitimate line. Now, switch to the Edit tab and click the Trim sub-tab so we can trim back some unneeded lines from our project. Start by selecting the Break Single option below and click on the line that you want to break, followed by the line you want to break it against. Then, switch to the Delete sub-tab and select the excess lines and click the Complete button above to erase them from the design. Unfortunately, there is another excess line outside the flange, so open the Trim tab and break this one as well. Then go to the Delete tab and delete it as before. Now, select Flange 2 from the flanges list above and switch to the Part tab to define it. To fix the other side, change to Flange 3, click on the Edit tab, then the Trim sub-tab, and follow the same method, this time remembering to break the lines both ways before deleting. Define this flange under the Part tab and select the Display button above to see our project taking shape. Next, we will make some additional flanges so we have more space to fillet edges, add text, stitches, holes, and dimples. Still under the Part tab, click on the Bend sub-tab, switch back to the Design mode, change the flange direction to up, type 24 into the Flange Initial Height field, and add 2 new flanges on either side of our project. Then select the Definition sub-tab and click on the Define All button. Now, to add some filleted arcs, select the Create tab and the Arc sub-tab. Start by clicking the Auto Trim checkbox, then change the radius to 0.5. Next, select Flange 4 from the list and create an arc by selecting the 2 intersecting lines in the top right corner. Then, select Flange 5 and do the same. Define all the flanges under the Part tab, then go back to the Create tab, change the radius to 3, and create the arcs on the lower intersection of the flanges. Of course, as usual, remember to indicate the flange you're working on by selecting it from the flanges list above. Then click the Define All button once more. Now we will create some stitches along the bends of our flanges. Switch over to the Create tab, select the Miscellaneous sub-tab, followed by the Stitch tab. Here, select the Along Line Cursor Select option, then change the number of bridges to 17, change the spacing to 2.5, and place the stitches on the outsides of each flange bend, making sure to select the bends from the flanges list before working on them. Click the Define All button in the Part tab and you can see the stitches added by changing the display. Back in the Create Miscellaneous subtab, switch over to the Tab and Slot tab to create a slot. Change the depth to 0.5, the width to 4, and the location from end to 4 as well. Then select flanges 4 and 5 to add these slots to the tops of them as seen here. Change the display to 3D shaded and select the Part tab and the Define All button once again to apply the changes to the design. Next, we'll add some text into the project. Go to the Create tab and the Text subtab to access the text functions. Start by selecting the Path Outline option in the Type of Text section and type your text into the Text Properties field below. Change the font size of the text in the Font Size field, the angle of the text in the Text Angle field, and check the bold and italic checkboxes. After you've adjusted the angle to the right degree, you simply click on the location in the display area where you'd like to place the text. Afterward, click over to the Miscellaneous subtab and select the Bridge option. From here, you simply adjust the angle of the bridge and use it to break up the path text lines that would otherwise leave you with big holes in your project. Doing this will allow you to define your project correctly and export it as a DXF without complications. When you come across an issue in defining the text, it is possible that the angle and placement of the bridge is the problem. In this case, the bridge on the B interferes with arcs and lines at the same time and must be adjusted. To fix this, simply delete the bridges we've created and realign them. I've decided to bridge the text horizontally, matching the angle of the text. Define under the Part tab once again to see the changes made. Now we're going to get ready to incorporate some holes and dimples into our design, but we'll need some points placed beforehand. Switch back to the Design mode and select the base flange from the Flanges list. Then go into the Create tab and the Point sub-tab to create some points. Type -12 in the Y field and select the top middle point as a reference for a new point. Now switch to the Hole sub-tab and select the Rectangle option. In the Hole Dimensions section below, change the width to 12 and the length to 6. Then simply select a new point in the display area to place the hole. After defining the project, select Flange 5 from the Flanges list and switch back to the Create tab and the Point sub-tab to place some points for dimples. From here, select the Entity Center button and click the far left border of the flange. Afterward, select the Entity Midpoint option and click on the upper edge of the flange as seen here.
Then, choose the Incremental option, zero out the Y field, type 2 into the X field, and click the point halfway up the flange to place a new point.
Now, select the Line sub-tab and draw a line as seen here. Switch back to the Point sub-tab and select the Entity Center button and click on the newly created line to place a point. Then, select the Angle option from the list and adjust the angle and the distance in the value fields below in order to place points for our dimples. When you're finished, select Flange 4 from the Flanges list and repeat the same process. When all the points have been made, click on the Hole sub-tab, select the Dimple option from the list, change the outer diameter to 2.5 and the inner diameter to 2. Then select the 4 points on Flange 4 to place the dimples. Now select Flange 5 from the Flanges list and place 4 more dimples as seen here. Now, with our part nearly finished, simply select the Part tab and the Define All button to ensure that we can export it as a DXF file. Finally, to export this file as a DXF, go to the Tools tab and select the Plasma DXF Export button. Name the part as you wish and select the Save button. The part file will now be available to send to your plasma cutter or another CAD program. Thank you for participating in our second Bentech 7X sheet metal plate tutorial. For more helpful and informational videos, click here to subscribe to our channel and like us on Facebook.